Okay, this video is to assist with your section 4.1 homework. This is the beginning of fractions. So I'm going to start with number 1, and I'm going to explain this to you. When you look at a fraction and you have a 5 on the top and a 3 on the bottom, it's going to ask you to identify the numerator. So this is terminology: numerator, denominator, and then to identify whether it's a proper or an improper fraction. So I'm going to get into that in a minute. Just understand the number on the top of the fraction is the numerator. The number on the bottom of the fraction is the denominator. Now, is this a proper or improper fraction? Well, anytime the number is larger on the top, if the numerator is larger than the denominator, then it's considered an improper fraction. So let me show you the difference of the three. Looking at these three examples, a proper fraction would be the first example because the numerator is smaller than the denominator. So that is a proper fraction. An improper fraction, as I explained, the numerator will be larger than the denominator. And this last one would be a mixed number. Now, these are the three that we're going to see within this chapter. Now, going back to our homework, let's go back and work on those. So now in number 2, it's going to give you three shapes. Now, in the first question, it's asking the improper fraction which represents the shaded area. So basically, if you notice down below in the denominator, I have a 4 because no matter how many different shapes you have, they're all equally divided into 4 sections. Since they're equally divided into 4 sections, that would be your denominator, the bottom part of your fraction. And then you count how many of those have been shaded. So you can see the first 2, there's 8, and then on the last shape we have 1. So that's why we have a fraction of 9/4, which is an improper fraction. Now, how do we represent this number as a mixed number, as you can see in number B? So let me show you how you represent that as a mixed number. So let me clear this out. And then we had 9/4. So that's 9/4. So how do we express that? Well, we turn that into a division problem. So I just create a division bar, and we take this 9 and we're going to plop it down here. So it looks like this: 4 divided by 9. So you have to remember the numerator always goes right inside there. So we start just performing long division. 4 goes into 9. Well, it goes into it 2 times, and 4 times 2 is 8. Now we subtract that out. Now our remainder becomes our numerator, and then our denominator never changes. So the answer to that would be 9/4 equals 2 1/4. That's how we express it as a mixed number. So when you're working on these problems, going back to your homework, you'll see that the mixed number, how do we represent? Well, again, we took that 9/4 and we turned it into a division problem, and our remainder becomes our numerator. Okay, number 3, same concept. We look at the triangle. If you count them, there's 1, 2, 3, there's 4 parts. It's divided exactly the same, both of those triangles. But when you look at the shaded area, so we know it's the 4 is our denominator, and we see what is shaded, and that becomes our numerator. So we have 5/4, and that's our improper fraction. And then to get a mixed number out of 5/4, we just create a division problem. So again, it would just be 5/4, and we're going to create that into a division problem. So it's into 5. We knew that 1 times 4 is 4. We subtract it out, and so that'd be 1 1/4. All right, going back to our homework. So let's move on to number 4. Now this one, it's just going to ask you simply to represent that as a fraction. So you count how many parts. There's 8, so that becomes your denominator, and how much is shaded, that becomes your numerator. So it's 7/8. Moving over to the next one, same concept. We're just counting these little little division parts, almost like a ruler. And so if you count those, you have 1, 2, 3, 4, 5, 6, 7, 8 to the very last point. And then only one of those 8 parts have been shaded. So your fraction is 1/8. Now, if we look at this one, this fraction, how many parts are shaded? Now, you can see all these images have 8 circles, but 2 of them have been shaded. So that's why C is the correct answer. Now, this one you're reading, you have American Sign Language, class of 15 students. 13 of them are hearing impaired. So what fraction of the students are hearing impaired? So when you're writing out these fractions, the whole number, the total amount is always your denominator. And then the partial amount is your numerator. So they're saying, how many out of 15 are hearing impaired? Well, 13 are. So that's how you express it. 13 out of 15 are hearing impaired. Now, looking at this, the hard drive of Aaron's computer holds 9 gigabytes of information. He currently has 2 gigabytes. So what fraction of the hard drive has he used? So it's saying that it can hold up to 9 gigabytes, so that should be your denominator, but he's only used 2 of that 9, so that's why you express it as a fraction of 2/9. Now, going over to number 9, so we're going to look at 21 regions in the nation contain casinos. So they're saying, assume the nation has 50 regions. So they're saying out of the 50 regions, 21 of them have casinos. So that's why you write number A, what fraction of the regions contain casinos? Well, 21 does, 21/50. So now the next question is, well, how many regions do not contain casinos? Well, all you need to do is so to understand that, let me clear this out. So looking back, we said 21 of them do have casinos. So if we have 21 out of 50 do have casinos, how many don't? Well, we just take 50 and we subtract that 21, okay? And then we'll come up with our answer, which is 29. So now that is our answer, we know 29, and then they're going to ask us, and that'll be number B, and then number C, they'll expect us to express that as a fraction, so it's 29/50. So going back so you can see the verbiage. So it's saying how many regions do not contain casinos. So we determined 29 because we took 50 minus 21, and then in C we expressed it as a fraction. All right, number 10. All you're doing, if you see the graph, if you count from 0 over to number 1, there is 7 points. So 1, 2, 3, 4, 5, 6, and the 7th is when you get to the number 1. So you're just going to drag that over to the 5th point to express 5/7. Number 11, anytime you see a whole number and a 1 down in the denominator, it's always expressed as a whole number like -8. So what I mean by that is it doesn't matter what number you have. If you have 100/1, that's 100. If you have -100/1, then that's -100. If you have -8/1, then that equals -8. You can see how it's expressed as a whole number when you have a 1 in your denominator. So you're going to see problems like that. And they also wanted you to get used to the idea of anytime you have a 0 up in a denominator, if you plug it in your calculator, it's 0 divided by, and it doesn't matter if there's a -10, because 0 divided by anything is just the answer 0. They always want, and then the answer is undefined if you had a 0 down in the denominator, and I'll show you that in a second. Anytime you have 2 numbers on top of each other, remember 2 negatives will give you a positive answer. That will always give you the answer 1. So what I'm saying to you, it doesn't matter how high the number is, whenever you express the same number in the numerator and the denominator, the answer is always 1. So like 8/8, that's 1. 10/10, that's still expressed as the whole number 1. So now going to the next problem, this would be the answer. This is the only time that you'll check is undefined. Whenever you have a 0 in the denominator, that is an undefined answer. So when you try to plug that in your calculator, 8 divided by 0, you'll get an error. Okay, so number 15. So how do we express this as a they want you to take a mixed number to an improper fraction. Well, let me show you how to do that. So we learned that if we have this, we know we just have to divide it to convert it to a mixed number. We took 2 divided by 7. We know that goes into 3 times. We subtract and we take the remainder and it becomes the numerator. So we've learned that. Now, what if we have something like 3 1/2 and we're going to convert it the opposite way? Well, how you do that, it becomes 3 times 2 plus 1 all over 2. So the denominator never changes. So you're taking these two and you multiply them and then you add that in. It's order of operations. So if you do that based on order of operations, you should have 6 plus 1, which is 7 over 2. So that's how we're going to convert those. So you'll have a couple like that. You'll have to do this one and the same thing. So this one would be 12 times 7 plus 4 will give you 88. And the 7, the denominator never changes. And then lastly, same thing, just change an improper fraction to a mixed number. It becomes a division problem. And remember, your remainder becomes your numerator and that denominator never changes. So let me do this one, the last one, quickly for you. So this one here, we'll do it one more time. So if you have 35 over 6, that just becomes 6 into 35. And we know that goes into it 5 times because 6 times 5 is 30. And we subtract it out and there's our remainder. So that would be 5 over 6. So the answer to 35 over 6, to make it convert it to a mixed number, our answer would be 5 and 5/6.